Cancer. It's a word we all know, and let's be honest, it can be a really intimidating one. But what is it really? How does one of our own normal cells just go rogue? How does it get so powerful, and what does it actually do to our bodies? Well, in this explainer, we're going to break all of that down step by step. We're going to go from a single cell all the way to the entire system, and hopefully demystify this incredibly complex disease. So here's our game plan. First, we'll tackle the basics. What is cancer? Then we'll get into the really cool stuff, the superpowers these cells use to survive and thrive. After that, we'll track how cancer spreads, figure out how doctors measure its progress, and then we'll tie it all together to see how it impacts the whole body. All right, let's dive right in with the biggest question of all. At its very core, what is cancer? Fundamentally, it's a disease of our very own cells. Think of your body as this perfectly organized community where every cell has a job, follows the rules, and knows exactly when to grow and when to stop. Cancer starts when just one of those cells decides to rebel. It just stops listening to the rules and starts growing and dividing completely out of control. So as these renegade cells just keep multiplying, they can pile up on top of each other, and that forms a lump we call a tumor. But here's the thing. It's not just a passive lump. It can actively start to invade the healthy tissue around it, kind of like a weed that starts taking over a well-kept garden. So that brings up the real million-dollar question, right? How in the world does a normal, everyday cell get these dangerous new abilities? What flips the switch that turns a good cellular citizen into a total outlaw? Well, scientists have figured out that there's a set of core abilities a cell has to pick up to become cancerous. They call them the hallmarks of cancer. And this idea was a total game changer for research because it shifted the focus from just where a cancer is to the underlying mechanics of how a cancer cell actually behaves. Basically, you can think of them as the superpowers a cancer cell has to develop. And this is where we see the first two superpowers in action. And honestly, the analogies are perfect. First, cancer cells don't need anyone's permission to grow. It's like their accelerator pedal is just jammed to the floor. And at the exact same time, they completely ignore all the signals that would normally scream, "Stop." It's like the brakes just don't work anymore. But it's not just about growing fast. Cancer cells are also masters of survival. See, our bodies have this amazing built-in safety feature called apoptosis. It's basically a self-destruct program for damaged cells. Cancer cells, though, they find a way to switch that off. They cheat death. On top of that, they figure out how to bypass the normal limits on how many times a cell can divide, giving them a kind of cellular immortality. Now, to keep all this runaway growth going, a tumor needs fuel, right? So cancer cells get another clever ability. They trick the body into growing new blood vessels directly to them to deliver oxygen and nutrients. And this leads to what is maybe the most dangerous hallmark of all, the ability to break away, travel through the body, and set up new camps in other places. And this ability to spread has a name, metastasis. This is what transforms a local problem into a body-wide disease. So let's take a quick look at how this actually works. You can think of it as this little multi-step escape plan. First, a cancer cell has to break out of its local neighborhood. Then, it needs to find a way onto one of the body's highways, like a blood vessel or a lymph vessel. From there, it travels through the system. And if it can somehow survive that really dangerous trip, it has to find a spot to pull over, exit the highway, invade a brand new tissue, and start growing a new tumor all over again. And, this spreading process isn't completely random. Different types of cancer tend to have preferred travel destinations. For instance, breast cancer often spreads to places like the bone and the brain, while colon cancer commonly heads for the liver and lungs. Understanding these patterns is absolutely crucial for doctors when they're figuring out how to diagnose and treat the disease. So, how do doctors even begin to measure all this spreading? Well, they use a system called staging. Think of it as a universal language that helps them describe exactly where a cancer is and how far it's managed to travel. The most common way they do this is with the T&M system. It sounds technical, but let's break it down. T is for the primary tumor. How big is it and how far has it grown locally? N is for lymph nodes. Has the cancer made it into any of the nearby nodes? And the big one, M, is for metastasis. It asks the critical question, has the cancer spread to distant parts of the body? All that detailed T&M info then gets grouped into the simpler stages that you're probably more familiar with, from 0 to 4. Stage 0 basically means abnormal cells are there, but they're contained. Stages 1, 2, and 3 mean there's cancer, and the higher the number, the bigger it is or the more it has spread nearby. And stage 4, well, that's when you know the cancer has metastasized. Okay, so this brings us to the final piece of the puzzle. We've seen how a cancer grows, we've seen how it spreads, but how does all of that cellular chaos actually cause harm to the entire body? One of the most direct ways is just by getting in the way. It's a simple physical disruption. A tumor growing in your digestive system can create a blockage, making it impossible to absorb nutrients. Or a tumor in the lungs could block an airway, making it hard to breathe and get enough oxygen. It's basically like a permanent roadblock on a critical highway. But the damage goes way beyond just physical blockages. Cancer can also throw the body's delicate chemical balance completely out of whack. For example, it can make bones release too much calcium into the blood. It can invade our bone marrow, which is the factory that makes all of our essential blood cells. Or it can mess with the liver, which is our body's main filter and chemical processing plant. Now, I know after hearing all of this, it would be really easy to feel discouraged, but I want to end on a note of incredible progress, and it all comes down to this one number, 50%. Today, in the UK, 50% of people diagnosed with cancer will survive their disease for 10 years or more. And just to put that into perspective, as this quote from Cancer Research UK shows us, survival rates have literally doubled in the last 40 years. That's not magic. It's a direct result of us understanding the very mechanisms we just talked about. This knowledge is what fuels all that progress. And that leaves us with a really hopeful question for the future. We've just walked through the biological rulebook that cancer has to follow. So as we get better and better at understanding and targeting each one of these hallmarks, how is that going to change the future of treatment? How will it change the way we fight and maybe one day conquer this disease?